Hello, this is Mr. Collier, and today we're doing types of data and measures of central tendency. Okay, so qualitative data measures quality, like color, gender. By color, yeah, it could be color or eye color or hair color or something like that. So those types of statistics are qualitative data. Quantitative data are quantities, so numbers, so like height, weight, arm span, things like that are quantitative data. Temperature is another one. Okay, then discrete data consists of numerical values in cases where data values can only take certain values. Or in other words, certain values are not possible, like for example, number of students. Okay, that would be a whole number. You couldn't have 1.5 or something like that. Okay, shoe size. Even though you can have a fraction, maybe a shoe size, there's certain values that you can't have in between. Okay, so things like that. Usually number of students or number of something when you're counting. Continuous data consists of numerical values where all values within a certain range are possible. Okay, for example, height. If you got a better and better measuring device, you can measure it to the nearest tenth or hundredth or 1,000th. Okay, so height and weight and temperature, time, yeah, anything that you can measure like that. Okay, so some examples of here's some examples. Colors of cars in car park is qualitative. Okay, it's quality. This is qualitative. Weights in an egg carton. Weights are quantitative and continuous, right? Sizes of ladies' dresses are quantitative, discrete. Number of goals, that's also quantitative, discrete. And the depths that fish swim, that's a continuous data, right? So it's quantitative, continuous. Okay. Now let's say we want to get the average of these numbers. So a lot of you would think automatically to average them, you would add them all up and divide by how many there are. Oops, plus 0, plus 1, plus 8, plus 3, divided by how many are there? There's 7 of them. Okay, so if you do that, you get 13, so or about 13.1. Now notice that 13.1 is bigger than most of the values here, right? It's this outlier here. Call this an outlier. Brings the average up a lot, or the mean up a lot. Okay, so that's why we have different types of mean for measuring things like this. It's not really representative of the values here. Okay, same thing happens with income. If you look at average income, there's some like billionaires that bring the arithmetic average way up. So we need different ways of measuring the average. So here's the 3 ways to calculate the average. The mean we just did. The median is the middle value if there's an odd number of terms. So it's just the n plus 1 over 2 term, where n is the number of data values. And if there's an even number of data values, then you got to get the average of the 2 middle terms, which you can describe as these 2 terms. Okay, so that's very useful in the previous case, or in the case of incomes. The mode is the most frequently occurring one. It can have more than one mode. 2 modes we call it bimodal, or more than 2 we call it multimodal. Okay, so that's the most frequently occurring data value is called the mode. Okay, so let's look at some examples. Here's a here's a survey for number of lunch meals bought per week in grade 11. Okay, they go from 0 to 5. And so when you have lots of data like this, you usually want to summarize it to a table. So let's do a tally for the number of zeros. Let's count the number of zeros. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I believe. 1, 2, let's try it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, there's 11 of them. And for the ones, there's 1, 2, 3, 4. For the twos, we have 1, 2, 3. Threes, 1, 2, 3, 4. The fours, 1. Fives, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have all that added up. Now to get the mean, we have 11 zeros. So I'm going to make another column. Sometimes we call this the fx column, because we're going to take the frequencies and we're going to multiply by the values x. Okay, because there's 11 of them that have 0 lunches, that's 0 total. 4 people with 1 lunch, that's 4. 3 people with 2 lunches, that's a total of 6 lunches. 4 people with 3 lunches, that's 12, and this is 4, and this is 45 lunches. Okay, so if you want to get the total number of lunches, you can add up this column. Okay, so I add them together, I get 10, 22, 27, that's 60, 72. Okay, so there should be 33 total students. Let's just double check that this is 33. Okay, actually if you add these up you get 32, so I missed 1 5 somewhere in here. So this should be 10 and 50, and so let's double check the whole thing again here. 10, 22, so that's 10, 22, 26, plus 50 is 76. Okay, so that should be 76, yep. So the mean is 76. Mean, we use a symbol, x with a bar over it. The mean is 76 divided by 33, which is 2.3, so about 2.3 lunches on average. Okay, so the mode is the most frequently occurring one, and that would be this one here with 11, so 0 is the mode. 0 lunches. Find the median. So that will be right in the middle. We have an odd number, so if you look back, the one in the middle is just going to be n plus 1 over 2. So that's going to be 33 plus 1 over 2, which is 17. So the 17th one is going to be the median. 17th one is, so we got 11 zeros, then we got 15 zeros and ones. So 17th one is going to be a 2. Okay, so the median equals 2. Okay, so next, often we have a lot of data, we put them into groups. Okay, so we can figure out how many are between 40 and 50 and then count those. This means including 40 but not including 50. So let's count those. There's a 40. Are there any more 40s? No, it looks like that's it. So there's 1 in the 40s. Okay, let's check the 50s. We have 1, 2 in the 50s. In the 60s we have 1, 2, 3, 4, 5, 6, 7. We have 7. In the 70s we have 1, 2, 3, 4, 5, 6, 7, 8. In the 80s we have 1, 2, 3, 4, 5, 6, 7, 8. 8. Looks like I missed one in the 70s, so I'm going to change that to a 9. And then in the 90s, we have 1, 2, 3. Oh, 3, 4, 5, 6, 7. Okay, it looks like I missed a couple more in the 70s. Huh? 1, 2 more in the 70s, so that's 11 in the 70s. So there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 times 2. Should be 36 data values. Let's double check this. So this is 10, 21, 21 plus 15 is 36. So it looks like there's 36 total now. Okay, now for this case, once you got them in group data like this, then you can estimate the mean by assuming like these eight data values here are all between 80 and 90, so we can assume they're all about 85. Okay, right in the middle. Okay, so on our best guess for these data values is right in the middle. So let's write those down. Okay, and then the fx column, we will multiply the frequency by the midpoint value. Okay, and then we get here 110. Okay, so that's going to be 2,780. So the mean is approximately 2,780 divided by 36, which is about 77.2. Okay, so that's what we just calculated, 77.2. For group data, we don't really have a mode. We have a modal class. Okay, that's the interval with the highest frequency. So in this case, the interval with the highest frequency is this one. So that's what we call the modal class. Okay. Modal class is just another word for interval. Okay, now we can do the same thing here. To estimate the mean, you get the midpoint, the mid-interval values, so the average of 10 and 25 is what? You add them together, divide by 2, you get 17.5 is the mid-interval value. Okay, and this one here is 32.5, 47.5, 62.5, 72.5, 77.5, I mean. Okay, then you need the fx column. Alright, which is 17.5 times 3 and 4 times 32.5 and so forth. Okay, so these are the totals, and it's the total of those frequencies. So the mean equals 2125 over 40, which is approximately, or actually exactly, well, it is an estimate, so I should use an approximately equal to sign. It's 53.125. Okay, and for the modal class, that's the one with the highest frequency. So the modal class is this one here, so it's 55 less than or equal to m less than 70.